Okay, so hi, my name is Peli de Halleux, and I'm going to talk to you about PEX today, a tool to do automated exploratory testing. So, hey, it's not a testing conference here, so how did we end up here? This morning, the reference project talked about 30,000 lines of Python and 100,000 lines of test. So we think that definitely writing test is part of the language experience today, and we have something to propose here. So it's a joint work with Nikolai Tillman, who's there sitting, and we are on the other side of the highway in research. So the outline is pretty simple. I'm going to start with a cool example to see how automated exploratory testing works, and then we'll see how it works in the inside. And if you want to, we can give you some greedy, needy IL low-level details. And then at the end, we'll show you what we think is a pretty cool development experience and definitely lowers the pain of writing tests while you're developing. You all know that we can look at the BCL code now. So we decided to take a look as well. So this is the resource reader that shipped with v10. It's used all over the place in WinForms and everywhere. This is the constructor of the resource reader, which takes a byte stream, and then it stores it somewhere. But the cool stuff happens in read resource, where so here we're in read resources, and the first thing that we do on the stream, so store is an interface to the stream. We read an integer and we check that it's a magic number. So if you're testing this code and throwing random number here, well, that's where you're going to stop, because you have a large chance of never making that magic number. And reading an integer is actually not trivial. And for my half peanut size brain, it's already starting to be painful here, where we do this bit shifting and bitwise operations. So the motivation here is to show that we're not toying around. This is a real code that's running on your machine right now. I'm a tester. What can I do? What I want to do? Well, there's a lot of things to do, but for a start, I'd like the code to not crash. And one way to do that would be for me to do a white box approach, look at the code, figure out what's the magic number, and start crafting inputs. So that would be kind of a test case that I would have written by hand. So you would have a first part, which is the data, and the first, remember those numbers. Those are the first 4 bytes of the magic number. And then in the second part, I would write a little scenario that uses the API and either in the test embeds some assertions to verify the properties, or rely on the assertion that the developer have crippled into the code. Right. So you can see that there is a flow into the constructor of the resource reader. Now, what we're proposing now is parameterized unit tests. So there's nothing new about parameterized unit tests. I know they exist as data-oriented tests. The idea is that the data, you take out the data. So you focus on writing the contract of the API, and then you let the tool figure out interesting inputs to cover the implementation. We're going to see what that means. So parameterized unit tests are the way that we expose this automatic exploratory testing to the user. And we'll see how they can change the way you're going to do testing in the future. So this is demo time. So the first demo is command line based. I'm a command.exe user. So we're going to launch PEX, our command line version, on that parameterized test that we've seen. And it's similar to existing test framework. We're going to figure out with reflection where is the test. And we're basically going to start crafting unit tests that call back into that parameterized test. So this is, so each time you see this test here, it means we have a new test that has been generated. So there's a lot of text here, so we're going to ask him to stop and see an even more verbose HTML report. So there's a lot of things on this report, but there's a summary here of all the exceptions that we've seen during the exploration of the code. So that one looks good, looks good, looks good, looks good, looks good. That doesn't look good. So what happened? Let's go to the test that triggered that exception. So we're here. So that's the test that PEX generated to go and hit this overflow exception. So if you remember the four numbers that we've seen in the past, we have the magic number and then some interestingly crafted integers here that were passed into our test. And that went into the resource constructor and then went into the code of the BCL. And so I didn't have the symbol set up, so I can just tell you what happened. An integer was read from the stream and then was used to instantiate an array. In .NET, if you try to instantiate an array of size -1, you'll get an overflow exception. So that's not good. And that's kind of the end of the first part of the demo. Oops, wrong one. Okay, so that was the demo. So we've seen an example of how exploratory testing can work. We have a parameterized test, and then we're going to start crafting different inputs to cover all possible behavior, hopefully. So how does it work? It works using technology called dynamic symbolic execution, which is very, very cool if you're a geek. And where does it sit in terms of other testing technologies? So we have static analysis, think verification. That's what your compiler does in a sense. And then you have more advanced tools like fxcop or SAL annotation for C or C++. And then on the other range, you have dynamic analysis, testers who do the job, white box, black box, all kind of things to make the software better. And so that's usually a manual job, and usually static analysis is fully automatic. With PEX, we want to be in between. We do some weird dynamic, we do some weird static analysis on the fly while the code is running. So with PEX, you need to write those parameterized tests manually, usually, to get some relevant scenarios. But then you can let PEX figure out the test inputs to cover the implementation. So at a high level, what is dynamic symbolic execution, which we call also automated exploratory testing? So we always start, let's always think about this resource reader example. We start with an arbitrary byte array, and the easiest one is the null reference, right? And we run the test and we monitor the execution. And we'll see in the next slide what monitoring means. It means that we're gonna track every instruction that the runtime is gonna do and keep track of the symbolic values on the side. So that's kind of so I'll talk more about that later. So we run the tests with real values, and we do a real run, and we record what's happening. And more importantly, we record where we take branches and why we took them or we didn't take them. So in the case of the resource reader, you remember that the first thing we do is reading an integer, and then we check whether it's equal to the magic number. So obviously, with our first guess was wrong, we probably passed 0, and then the condition to hit this execution path had this expression here, that the magic number was not equal to this number, right? So we continue executing, and we get a tree of branches that we didn't hit, right? And so this is where the exploratory testing comes in. We pick a new branch that we want to cover, and we look at the expression that was guarding it. So let's go back to the if statement involving the magic number. Well, there was this condition that was not true, right? What we can do is negate it. So the next time this is true, and then pass that. So we build a constraint system that is composed of the pass condition to reach that branch, and then also plus that condition to make it true or false. And then we pass that to a constraint solver. So we use Z3. That's also developed in research. And we have Z3 for a solution, a concrete example that will make that true. And then once we have that, we transform that back into code, and we can just run the code. And we might now hit new. So in the case of the resource reader, we will pass that branch, that through in terms of the magic number, and we will start executing new code, seeing new branches, new behavior. Then we will want to test them as well. So this is where the exploratory testing comes in. It's an iterative process where we go deeper and deeper into your code as we craft new inputs. So how does it? So since the audience likes to get low level in the CLR, let's look at how this is done in terms of how we monitor the code. So in a life, when you're a user of the .NET, you're in your managed world. Everything is really nice, and you're using the .NET runtime, which is a mixture of managed and unmanaged and all those things that we don't want to know about. So the CLR provides us APIs to implement a profiler, and one of them we are able to rewrite the method body of any method just before it's JITed, right? So with PEX, what we do is we're going to insert manage callback basically before every IL instruction, and I'll show that in the detail in the next slide. And what we end up is really it's a managed execution monitoring framework, and on top of that, it's really easy to build this dynamic analysis tool. So we build on top of Profiler to rewrite the code. So let's look at a very simple example. We have the class point, which has two fields, and then this method that checks whether P is null and returns X. Otherwise, it just returns -1. Right. So I assume. So who's familiar with IL? Okay, that's pretty good. We've seen much worse. So the original code would look like this. Okay, we load X on the stack. We check whether it's null. Otherwise, we set up the branching. Otherwise, we load the value of the field X. Otherwise, we should load -1 somewhere. Okay, and then return. The real code will look a little bit more complicated in debug mode. You have a local. This is the demo, so there might be errors. So the first thing that we do, we add some prologue, epilogue to know that we got in and got out of the method. As I said before, every IL instruction, we're going to add a callback. So those are managed callbacks to our APIs. It's not finished. We also add callbacks to monitor the program flow. So this helps us monitor our data flow. This will help us monitor program flow. So we'll know we're going to take a branch, and then we took that branch, or we took the other one. Or we took that branch, or we took the other one. And then we also have some catch handlers to figure out whether we had some unexpected exception. So if we difference X from a null pointer, we should get the null reference exception. So PEX knows about all those implicit branches that are defined by the .NET runtime. And there's more instrumentation. And just for the fun of it, let's see. We have an internal logging infrastructure to dump IL. So this is a simple method that branches over a value. So that's the original IL. You have load the first argument, and then this static field. You check whether it's equal, negate it, store it in a local, and then branch. And if it's true, you throw this exception. So that gets blown up into let's start here. So we have this entering method. We have this argument logging. We're gonna figure out which field exactly we're gonna access. Load field. And then you can see here CEC, load 0. So it's there's a little overhead, but it's very, very precise. And probably uglier than the JScript of Volta. Okay, so a bunch of limitations that are really tough to handle. We suppose your program is deterministic. That means no randomness. If you call into native code that has a state, if you go into web services, database, or things like that, that's going to be a trouble for us. We only understand MSIL. We cannot rewrite C or C++, and we cannot rewrite the Win32 API. And so basically, when we run them, we cannot build the constraints, and we won't be able to cover them correctly. Single-threaded, that's something we're working on, but so we cannot help you in there right now. And most importantly, it's for unit testing. Don't point it at your main method and hope that we're going to solve all your problems. There's work to do on your side too. So that was about how dynamic symbolic execution works, and now we want to show how PEX can work to help the development experience in Visual Studio. So the demo here is a simple string chunker. We want to write an application that cuts a string into pieces. And let's say we have a specification that says that when we partition the string in pieces and concatenate the pieces again, we should get back the original string. So let's translate that into a parameterized test and run it and see how we're going to implement this chunker. Okay, so I'm in Visual Studio. I have a test project, and to speed up the demo, I have an empty boilerplate chunker. So the next method will return the next chunk until it's done, and then it will turn null at that point. And it takes the string and the length of the chunk. And here we have a test class. It's a test classic VSTS or NUnit or any test framework test type. And then we have our own little attributes. So this is a PEX method, meaning this is a parameterized unit test. So since we have to go really fast, I'm going to cheat and copy the parameterized test. So what did we do? We instantiated a chunker and then looped over the chunks and added to that local result. And at the end, we can simply use VSTS assert type to check that it should be equal to value. So I can right-click in the method and tell PEX to explore that particular method. So we're going to launch a process in the background that's going to be instrumented, and we're going to start feeding back unit test. So here you can see the UI that we have 2 rows. So every row is a unit test. And let's see what they look like. So we've added a file in the project that contains the generated test. And those tests are really simply calling back into your parameterized test, right? So the first one is really easy. We passed null, and actually the assert didn't trigger because null was equal to null. And in the second case, PEX decided to generate the empty string as a string. So why was that? Well, that was simply because in the assert are equal, there is a branch if value is not equal to result, throw. So PEX analyzed that method and tried to cover that particular branch. And that's why we got the empty string. But there's nothing random here. So okay, this implementation is really too trivial. Let's replace it by, oops. Okay. So let's hide this guy. So now what do? We store the 2 values here, and we also have an index local, and then so we're going to loop and extract a substring and then update our index. So this has a lot of issues. It's obviously going to generate problems. So we can just run PEX again. PEX is going to take care of doing some cleaning up of the generated test case when it changes behavior. And in this, in the development setting, we stop after 2 failures, and then we let you look at it. Otherwise, we could have much more. So we have 2 problems. First was the null reference. So I guess we can do the game. Do you know what happened? So value was passed, was taken from here, passed here, and nobody ever checked whether it was null. So one interesting feature that we have in PEX is that since we do this control flow and data flow analysis, we can infer fixes for your code for those kind of errors. So when you break the contract of an API or the CLR kind of general contract, like you cannot defer a null reference, then what we can do is lift the contract to the first public call that didn't do its job. So in this case, really we want to check in the constructor. So now I'm going to say fix it, and PEX knows from the data flow that it has to put the fix there. So the fix is not really interesting, but really it's knowing where to put it that's more tricky. And of course, since we know this for arbitrary expression, it works also when you go out of range. So let's fix this guy, and we have our second expression. So our second check says that the length of the value should be smaller than the length and things like that. Definitely review the expression. But this gives you an idea of what we think should be a nicer experience where you're developing. So we've done changes in the code, so we can just rerun the test. So I'm just using a shortcut here. PEX knows I'm working on that particular test, so I don't have to tell him. I didn't mention it, but here we have a coverage view, which in this very short case doesn't show much. In realistic situation, PEX can run a long time, and you can see how the coverage goes. So now that we've added text, PEX says, "Whoa, you're throwing this argument null exception," and this raises the error of how you're going to filter exceptions. How do you know an exception is expected or not? Right now, for the demo, we're just going to allow it. And oops, that didn't work. So I'm going to allow it manually. Oh, it worked. So we have a lot of attributes. That's one of them, which says basically exceptions, argument null exceptions are okay to be thrown. And probably, okay. So now I can, I'll say that any argument exception is okay, and I will also allow subtypes, just too short. So I can just run again PEX. Where is the test? So now the 2 first test case passed. So here we can see, I didn't mention that, but this column is the value, and this is the length. So you can see, you have a quick overview of what has been generated. So PEX generates new inputs, and basically at this point, it stopped, and we think it's in a good shape. So what you can do now, you can just open test view. You have a list of unit tests that you can just simply run with VSTS, check them in, look at the coverage, and things like that. So that finishes the Visual Studio demo. Yeah, always the wrong one. So what did we do? So we call that exploratory test-driven development. not the best name ever. So what happened? We write a contract, parameterize unit tests, and then refine the code, run pegs. Pegs might give us fixes, or might give us failures that we can debug with a regular debugger, because they are just unit tests. And then we can iterate. And the key here is that the loop is here. You're working on the code, and not on the test. If you think about the demo, I wrote the test at the beginning. I never came back to it, and we just worked on the implementation. That's what you're paid for, and that's what's running on the customer's machine. In terms of how we expose it to the customer and to the user, we integrate nicely into existing unit test frameworks, especially the one that use custom attributes. So we have the unit test attributes that get generated on the unit test. We use the partial class, so the files get populated in the project system. And then we have our own set of attributes to mark and help the user tune the zillions of parameters that we have. And basically the idea is that you start from parameterized tests, and we'll craft inputs to cover the implementation. So in summary, we've shown automated exploratory testing, which brings a separation between the specification of the behavior and how you get covered during your implementation. It also encourages testable design. That's also a side effect of unit testing. We have a new development experience in Visual Studio based on that technology. This works at the MSIL level, so it works for any .NET language. Whereas the download, there's a download for academic license. There's an academic license for non-commercial use. Send us an email. Stay tuned. Things change. And I'm not sure if I'm too quick or since the schedule changed, I don't know where I am.
Take questions on the side while we set up with the next speaker.
Okay.